Hello, beautiful people, and welcome. In today's video, we are discussing exact trig ratios. And a reminder, I am human. If I make a mistake, please let me know so that way I may learn from it. A secondary reminder for my class, make sure that you have your values memorized. You will have a test on this timed where I am going to ask you specific values, and you need to be able to have an answer without a calculator, without any cheat sheets. Let's go ahead and get started by going back to yesterday's lesson about a unit circle. If you know quadrant 1 on the unit circle, you should be able to derive all of your other values. Let's go ahead and sketch out quadrant 1. I am going to leave a little bit of space because for quadrant 1, we are also asking you to have your half a cycle, your 180s, and your 360s. So here's quadrant 1. We have our 0 or our 360 degrees. Let's start here on top. Here's 0. Here is 0 radians, 360 degrees, or 2 pi. Now, halfway between 0 and 90 degrees, which is pi halves, we have our 45-degree angle, which is also known as pi over 4. Again, you should have that from yesterday's lesson. The other way is we're going through 30 degrees. Here's 30 degrees, or also known as pi 6. You should have that memorized from yesterday. And 30 plus 30 is 60. Here's 60 degrees, also known as pi thirds. Now, there is a trick to knowing what your ratios are, what the answer is to the question. Let's actually complete this before I move on. Here's 180 degrees, also known as pi radians, and 270 degrees, also known as 3 pi halves radians. And the trick is knowing your x and y values for each of these. Let's go ahead and do here's x and y, here's x and y, here's x and y. Now remember, you do need to have your unit circle memorized. All of these values, including all of the angles, in less than 3 minutes. We'll test on that, we'll practice on that. And each of these has a location of a point that represents the location of the point on the unit circle. So if we were to go around in a circle, that would be our unit circle. So here on our x value, we have 1 and 0. Here on our y-axis, we have 0 and 1. On our x-axis, we have -1 and 0. And here we have 0 and -1. The next one I like to have memorized is my 45 degrees, which is your pi fourths. All of these will have a denominator of 2 if you want to go ahead and write in your denominator of 2s. And we have our square root of 2 here, square root of 2 here. How you have these memorized, it's up to you. How you want to spend your time filling in these values on your timed unit circle is also up to you. The way that I like to do it is I like to focus on 45, go around for 45, then I like to go on my 30s and then my 60s. There's also tricks to it. For example, if we start here at 3, 6, 3, it's going to be square rooted. And then here's the pattern. If you notice there's a 3, there's a 2, and there's going to be a 1. So if we go on our x values, 3, 2, 1, so that means on our y value is going to be 3, 2, 1. Now 1 is square rooted, right? If we were to follow the pattern, this is still square rooted, but the square root of 1 is just 1. So again, mathematicians, we're not going to write the square root of 1 when we know the square root of 1 is just 1. So again, pattern. Divided by 2, 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 divided by 2. Okay. Then we have the square root of 3, square root of 2, square root of 1, square root of 3, square root of 2, square root of 1. Now these all come from your 30, 60, 90 triangle, your 45, 45, 90 triangle. That's where this is coming from with the hypotenuse of 1. Now, each of these values has a representation to the triangle, but also to kind of help us with our answers. Your x values, it's kind of like a cheat code. Your x values, whatever this value is, that's going to be your answer to cosine of theta. In that location, that's the answer to your cosine of theta, whatever that angle is. In your y location, that's going to be your answer for sine of theta. And if we know what sine and cosine is, tangent of theta is your sine of theta over cosine of theta, or taking your x value and your y value and finding that out. So this is our cheat code. Let's go back to quadrant 1. What I mean to say is, let's find myself a different color. If I want to know what cosine of 0 degrees is, it is 1. If I want to know what sine of 2 pi is, it is 0. If I want to know what sine of 360 degrees, it is 0. So whatever this angle is, I know the answer of it for sine, and I know the answer of it for cosine. Same thing here. Let's go here. This is our cosine answer. This is our sine answer. I'm just going to put theta. Here's our cosine answer. Here's our sine answer. Here's our cosine answer. Here's our sine answer. And for every single value on the unit circle, we already know the answers for sine and cosine of that angle. So for 90 degrees, sine of 90 degrees is 1. Cosine of 90 degrees is 0. And we can do that same thing for radians. Here is cosine of theta. So cosine of 180 degrees is -1. Sine of 180 degrees is 0. Here's your cosine. Here's your sine. Now, I did not put things like quadrant 2, 3, and 4 on here because we technically, besides having it memorized for a unit circle, for the exact trig ratios, we technically don't need those values memorized because I can find those values based off of quadrant 1. If you have these values memorized, great, but we'll be using quadrant 1. You still, yes, need them memorized for your unit circle, just not for exact trig ratios. It's going to be asking something a little bit different. Now that we're here, let's go ahead and show you what these questions are going to look like. Let's start with sine. The questions that I'm going to ask you is going to be in radians along with degrees. And I am going to ask you of things like, let's go in order. Let's start with degrees. Sine of 0 degrees, sine of 30 degrees, sine of 45 degrees, sine of 60 degrees, sine of 90 degrees, sine of 180 degrees, sine of 270 degrees, and sine of 360 where we started the initial. Again, these you should already have memorized, right? This is based off of a unit circle, but because it's day number 1, let's go ahead and go back to where are we getting these answers from. We're looking at quadrant 1. Here's quadrant 1. And we're looking at our y value. So here's sine of 0 or sine of 2 pi. Here is sine of 30 degrees. Here's sine of 45 degrees, sine of 60 degrees. So all we're looking at the y location of the quadrant 1. So sine of 0 degrees in the y location, we have 0. Now this 0 does not have any units attached to it. It's just 0. Next, we're looking at 30 degrees. Here's 30. Here's your y location. Sine of 30 degrees is 1/2. 45, 45, that means root 2 over 2. 60 degrees in the y location is root 3 over 2. 90 degrees gives me 1. 180 gives me 0. 270 gives me a -1. And 360 gives us 0. Again, where did these values come from? They came from the y location of your point on the unit circle. Now let's do cosine. Cosine is going to be the x location. So I'm going to copy this out. Cosine of 0, of 30, of, oops, not sine, cosine. We're doing cosine. See if this works. Will it work? Of course not. Here's cosine of 45, cosine of 60, cosine of 90. Seems like I'm off, but I just wrote them closer to each other. Cosine of 180, cosine of 270, and cosine of 360 degrees. Okay, now we're looking on the x location. So here's all of our x's. So 1, root 3 over 2, root 2 over 2, 1/2, etc. So we're looking at our x location. So at 0, we have cosine of 0 is 1. 30 degrees cosine is root 3 over 2. 45 is the same for sine and cosine, root 2 over 2. 60 degrees cosine is 1/2. Cosine of 90 degrees is 0. Cosine of 180 is -1. Cosine of 270 is 0. And cosine of 360, we are back at 1. Again, these should be memorized. Okay, next one, we have tangent. So we got tangent of 0, tangent of 30 degrees, tangent of 45 degrees, tangent of 60 degrees, tangent of 90 degrees. I know once we derive this, once we come up with these tables, beautiful people, then it'll be a little more entertaining on the lesson. We just have to get through this together. All right. Now, tangent is your sine over cosine. Let's go back here, sine over cosine. So for each one of these answers, I'm going to take my sine, I'm going to place it over my cosine, I'm going to divide, and then get an answer. Switch to pencil. Sometimes you need to erase on this one. Sine over cosine. So 0 over 1 is 0. Sine over cosine, 0 over 1, 0 divided by 1 is 0. Okay, next up, tangent of 30 degrees. Sine is 1/2. Cosine, you're going to do a little bit of keep, change, flip. I'm going to write out the answers root 3 over 2, but again, it's sine over cosine. Oops, over 3, not 2. Tangent, sine over cosine. It's the same thing on top, same thing on the bottom. Tangent of 45 degrees is 1. Then we got tangent of 60. 60 is root 3 over 2 sine. Cosine is 1/2. This one does not need, it still will do keep, change, flip. Crossing the 2's out, this will be square root of 3. 90, because now we have 0 in the denominator, this is actually undefined. 180, we got 0 over -1, which is 0. 270, -1 over 0, this is also undefined. And then we're back to 360, which is our initial rate. 0 over 1 is 0. Again, you should have these memorized. Now, not only do you need to have all of these values memorized, you do need to also have the radians memorized. Now, the values are exactly the same. The only thing I'm going to be changing is these degrees will now be in radians. Let's separate this out. We have sine of 0 radians, okay? So no degrees here, don't put degrees. Then we have sine of pi sixth, sine of pi fourth, sine of pi third, sine of 90 degrees, which is pi halves. Then we got sine of pi, which is half of a cycle, sine of 3 pi halves, that's 270, and then sine of 360, one full cycle, is 2 pi. Now again, even though it looks slightly different, these are exactly the same values as we did in degrees. So we're looking for sine. Sine, we're looking at the y values. Here's our answer for sine. So if I want 0 radians, I look for sine on the y. For radians, I get pi 6, sine, 1/2, etc. Okay, let's go ahead and write these out. These are the same values as before. So we got 0, sine of pi 6th is 1/2, sine of pi 4th is root 2 over 2, sine of pi thirds is root 3 over 2, sine of pi halves is 1, sine of pi is 0, -1, and 0. Same thing for cosine and tangent, and then we'll start with our actual questions. We got cosine. I'm just going to write cosine first, and then I'll go back with my angles. Hold on, maybe I'm going to not do that. Let's see if I have made a mistake. So we got 0, we got pi 6, pi fourths, pi thirds, pi halves, pi, 3 pi halves, and 2 pi. Okay, these are good. And again, if you want to pause the video or forward the video here, these are going to be exactly the same values for cosine. Again, where are they coming from? The cosine comes from your x location on the unit circle. So all of these values and these angles are coming from quadrant 1. All right. We get cosine of 0 is 1. Cosine of pi 6 is root 3 over 2. Cosine of pi 4th is root 2 over 2. Cosine of pi thirds is 1/2. Cosine of pi halves is 0. Cosine of pi is -1. Cosine of 3 pi halves is 0. And cosine of 2 pi is +1. Again, you should have these memorized. And the last one we have is tangent. And again, we're doing radians, so 0, pi 6th, pi 4th, pi third, pi halves, pi, 3 pi halves, and 2 pi. And again, we're taking our sine over cosine for tangent. So 0 divided by 1 is 0. 1/2 divided by root 3 over 2 is root 3 over 3. This one needed to be rationalized, the denominator. Root 2 over 2 divided by root 2 over 2. These are same top and bottom. That simplifies to 1. Root 3 over 2 divided by 1/2. Keep, change, flip. The 2's cancel out. We're left with root 3. 1 divided by 0 is undefined. Then we got of pi, sine over cosine. 0 divided by -1 is still 0. -1 divided by 0, that's undefined. And we're back as 0 divided by 1, which is 0. Okay, so these are the values on this page for your degrees and radians that you need to have memorized. This is not a let me think about it situation. This is a you need to be able to, within a microsecond, millisecond, if I ask you cosine of 60, immediately you need to answer with 1/2. If you're unable to do that, that means you have a lot more studying to do and preparation at home. Create flashcards, look at videos on best ways to memorize it. There's hand tricks, like hand tricks on it. There's things that you can write on your hand, not for the test, but for your studying. So definitely take a moment to see what tools are there to have these stuff memorized. Now, the actual questions. What am I asking of you? Let's start with something like this. Again, this is going to be timed. So for question number 1, let's say I ask you without a unit circle. So this is just a statement, and then you need to give me an answer. What is sine of 120 degrees? Let's start with degrees. In your brain, there should be a couple different things that you need to do. I separate this out on purpose. The first thing you need to do is in your brain, you need to draw the angle. And I don't mean that in a silly way, like, draw it in your brain. Actually picture it. Where is it? The reason you do need to do this is because you need to know what quadrant is the angle in. Depending on the quadrants that you have, there are things that are going to be positive, negative. In quadrant 1, all sine, cosine, tangent, and their reciprocal functions, the answer are going to be positive. If, however, it is in quadrant 2, this is quadrant 1, quadrant 2, we're taking a look at the unit circle. Let's see if I have one. I do. I have one here. Here's a unit circle. Notice how all of the x's are negative, the y's are positive. So that means x's are cosine. That means cosine is going to be negative, sine is going to be positive, and tangent, because it's sine divided by cosine, is going to be negative for your answers. Next, in quadrant 3, taking a look at quadrant 3, notice both the x's and the y's are negative. X's and y's are negative. X's and y's are negative. Because the x's and y's are negative, that means cosine is going to be equal to a negative value, sine is going to equal to a negative value, and tangent is going to be equal to a positive value. Remember, tangent is sine divided by cosine. Cosine is your x value, sine is your y value. Next, moving on to quadrant 4, let's take a look. In quadrant 4, we have a positive x, negative y. So that means positive x, that means cosine is going to be positive. Sine is going to be negative. That means sine divided by cosine, tangent is going to be negative. And there's a little trick to memorizing what is positive in each one, and that's called all students take calculus. So all are positive in quadrant 1. Students are positive in quadrant 2. Take, tangent is positive in quadrant 3. Calculus in quadrant 4. So again, the trick to memorizing that is all students take calculus, and the letter that it starts with, all are positive, sine is positive, tangent is positive, cosine is positive. That's how to memorize it. So when we're looking at this, we're going to ask ourselves a question. What quadrant is this in? You can do this in your brain. So this is going to be, okay, here's 90 degrees. This is happening in your brain. Here's 90. Here's 180. So here's 120. So this is in quadrant 2. And in quadrant 2, sine is positive. So even though we are not thinking about the quadrant 1, we're still going to be thinking about what quadrant it is in. So if this is 120, it's in quadrant 2. In quadrant 2, sine is positive. Next, you're going to then, step number 2, you're going to ask yourself, what is the reference angle? And eventually these are going to, again, you're going to have these memorized. You're going to say 120. Well, if I'm at 120, the reference angle is going to be this angle here. And the reference angle is going to be used to help you with your memorization. It's also reference is going to be a size that is in quadrant 1. It's not, it's in quadrant 2, but it's a reference. It's a size of quadrant 1. So this reference angle is 60 degrees. So 120 is the angle we have. The reference angle of that is 60 degrees. And I'm trying to go a little bit on the slower side so I don't lose you. Okay, ready? 3. Trig ratio. This is the actual question. Okay, so what are they asking us? They are asking us for sine of 120. Sine of 120 can be rewritten as sine of 60 degrees. Do you see how we have 120 as our given? The reference angle can be used to solve. Okay, now sine of 60 degrees, that is on your memorization sheet. If you need a moment, that's fine. I'm going to bring out quadrant 1. Sine is our y. 60 degrees is here. So sine of 60 degrees is root 3 over 2. And this quadrant 2 that we did, that states all students, right? Sine is positive. That means that our answer is going to be positive when we rewrite for one last time. Sine of 120 is equal to a positive root 3 over 2. Exhale. It's going to be okay. Let's try a few more before I let you go. Let's go again. Let's do radians this time. Let's say we have let's say they are asking us to evaluate what cosine is of 4 pi thirds. Okay. Step number 1, you're going to draw the angle in your brain. Initially, we spend a lot of time drawing the angle on paper. If you still need to do that, that's fine. That's okay. This is day 1, right? So if you need to draw the angle, that's okay. But how do you draw an angle with a denominator of 3? You can split this up. This is, again, directional. We're talking about the unit circle, so it's going to be going up. So I can split it up as 3 over 3 plus 1 over 3. That gives me 4. That means I have half of a cycle. 3 divided by 3 is 1 pi. And then I have 1/3. 1/3, if you want to equivalent that to degrees, that is 60 degrees. So more than half a quarter. So we're here starting. We're going half a cycle, 60 degrees, 5/3 is going to be here. That means our reference angle is pi thirds. We're not there yet, but I do want to just write that down so I don't forget. What quadrant are we in? And that is in quadrant 1, 2, 3, quadrant 3. In quadrant 3, all students take, the only thing that's positive is tangent. So in quadrant 3, cosine is going to be negative. Okay, step number 2, the reference angle. What is the reference angle? And again, this is all going to be memorized. None of this writing in English or anything. This should be happening in a split second. Okay, what is the reference angle? The reference angle to 4 pi thirds is 1 pi third, which means, again, we're now doing this into given to us is 4 pi thirds. Reference angle is pi thirds. So now we can use that pi thirds to solve for cosine of 4 pi thirds. Cosine of 4 pi thirds is now cosine of pi thirds. Cosine of pi thirds, cosine is our x value, pi thirds is 60 degrees. We get 1/2. And again, that should be memorized already. But because we're actually looking for an angle in quadrant 3, our answer is now negative 1/2. Okay, let's do a couple more. And pull up some questions. Question number 3. All right, I apologize for that. Just pulling up some questions. And let's say we have something that looks like this. Question number 3, I apologize for that. Just bringing up some questions. Let's say we have the tangent of 7 pi fourths. Okay, 7 pi fourths. Question number 1, we want to draw out, or step number 1, the angle in our brain. So split this up. You can do this 2 different ways. You can overshoot, like I know 7 is pretty close to 8, and then I'm going to retract back 1. 8 divided by 4 is 2, so this is a full cycle minus a fourth, right? 1 pi fourth is half of a quarter. So this tells us that this should be in quadrant 4, where we have removed back. So if I go 1 full cycle, it's too much. I am removing that pi fourth, which tells us that the reference angle is going to be pi fourth as well. Step number 2, actually step 1, number 1 still, quadrant 4. All students take calculus. Calculus means cosine is the only thing positive. Tangent in quadrant 4 is going to be negative. So now we're looking at our reference angle. Reference angle to 7 pi fourths is 1 pi fourth. So we have 2 things. We have tangent of 7 pi fourths. This is our given. Our reference angle is pi fourths. Tangent of pi fourths is 1. So when we combine these, including our quadrant, we have tangent of 7 pi fourths is equal to negative 1. Negative because it's in quadrant 4. 1 because tangent of pi fourths, the reference angle, is 1. Okay, let's go again. Right, we haven't done anything with a denominator of 6, so let's go ahead and do a denominator of 6. Did we do something with the denominator of 6? No, we didn't. All right, let's do cosine of 7 pi 6. Okay, step number 1, let's draw the angle in our brain. Please do not think you have to draw the angle. If you can visualize where 7 pi 6 is, you don't have to do that. Just tell me what quadrant it is in. If you do need to break this apart, that's fine. You can overshoot. But overshooting like this may not be beneficial because now you're going to have to simplify a fraction like 8 over 6. Why is that? That's not important. So instead, I'm going to go under 6 pi 6 plus 1 pi 6. This is a half. This is a 6 more. Here's a half. Here's a 6 more, which ends up giving us a reference angle of pi 6. This is in quadrant 3. All students take calculus. So that means tangent is the only thing that's positive. So if it's asking for cosine, cosine is going to be negative in quadrant 3. The reference angle is going to be pi 6 or 30 degrees. So if we do cosine of pi 6, again, 3 and 6 have a relationship with each other. This is 30 degrees. Cosine is our x value. So we're looking at this value here for our answer, or we're looking at the 30 degree here, pi 6, for our answer, which is going to be root 3 over 2 for quadrant 1. But since we are in quadrant 3, cosine of 7 pi 6 is going to be a negative root 3 over 2. Okay. Now we go into the reciprocal functions. For the reciprocal functions, you're going to have your values and then flip them. What I mean by that is you have your memorized values of quadrant 1, and then if you need to find reciprocal functions, you can by just flipping the value. So let's say, for example, this will be our last example. This video is getting a little bit longer. Let's say we have secant of 3 pi fourths. Step number 1, same thing as before, you're going to draw the angle in your brain. If you need to draw it out, that's fine. So I'm going to overshoot. I'm going to say 4 pi fourths, and I'm going to pull back 1 pi fourth. The trick is if you have a denominator 4, your reference angle is always going to be pi fourths. Again, this is for exact unit circle values, for trig values. If your denominator is 4, you're always going to have a reference angle 4. We still need to know what quadrant it is in. So we have half a cycle, but pull back 1/4. So our reference angle is always going to be 1/4 here, not touching the y, but touching the x. So we are in quadrant 2. Quadrant 2 is all students. Sine is the only thing positive, not secant, sine. That means the reciprocal function of secant is cosine. Cosine then is going to be negative. Okay, step number 2, we want a reference angle. Reference angle is going to be pi fourths. We already said that. So that means cosine of pi fourths is root 2 over 2. But again, we don't have that. We have two different things. First of all, we have this in quadrant 2, which means the answer to cosine is going to be negative. So it's now negative root 2 over 2. But we don't even have that. We have the reciprocal function. So secant of 3 pi fourths means I'm going to be flipping 2 over root 2. And the sad part is we got to now rationalize the denominator. So here's root 2 times root 2. Secant of 3 pi fourths is now equal to negative 2 root 2 over 2. And again, secant of 3 pi fourths is just now negative 2. This one does take about I don't know, 30 seconds to actually complete on a timed test, maybe up to a minute, but no more than that. All right, beautiful people, it's been a longer video. I apologize for that. I had no intention of making it this long. But here we are. Please take a moment to practice. These are challenging at first to memorize, but once you have your table memorized for quadrant 1, radians and degrees, this right here, it should be easier for you. Make sure to practice these. Make flashcards. Use tools of memorization. Make sure these are all memorized. Thank you so much for watching. Take care.